My name's Brian Cunningham. I've been with ELPRO for about 10 years now, and I've been in the wireless business for roughly 20 years now. Prior to that, I worked for a couple of different manufacturers of instrumentation products, and then prior to that, worked as for a local distributor here in Vancouver, where we sold every different type of instrument you could possibly imagine. Boy, it's been a really interesting career, I have to say. Tell your kids, engineering is a great way to go. Okay, so let's just jump right into it. ELPRO has been around for over 35 years. I think it's 38 or something like that. And the company was founded in 1983 by two RF engineers. And then they ran the company and built it up very successfully, until they reached retirement age around the year 2007, and they sold the company to MTL Instruments. Then in 2009, Cooper bought MTL Instruments, and then in 2012, Eaton bought Cooper. And then finally, Eaton did a very large restructuring. They sold off many different business units and acquired others. ELPRO was sold in 2018 to a private company called Aquamonics, based in Australia. Aquamonics manufactures flow meters and irrigation control equipment, among other products. And there was a very good synergy with ELPRO, as the folks at Aquamonics had used ELPRO products for many years. Just a reminder, we are going to record this session, as Matt mentioned earlier. So if you could please mute your microphone so that any coughs or sneezes are not recorded for all of eternity. Okay, now if you did have any questions, how about we hold those till the end? We should have quite a number of people on the presentation, so I think it'll be a little bit disruptive if we allow questions at any point there. Now this slide here is talking about some of the major achievements of ELPRO. One of them is a global range of products. So it literally does not matter what country the end user or the customer is building something in. We likely have a radio that fits those regulations. Keep in mind that every country has their own FCC equivalent, so the radio regulations can vary somewhat from country to country. ELPRO was the first company to release a true peer-to-peer I/O radio, which meant that we no longer required the master radio to coordinate and control all communications. We could go directly from one remote site to another. We were the first company to build a meshing 1-watt 900 megahertz radio. Now there had been a couple of other meshing technology radios released prior to that, but none of them had put them on a high power, long range platform like ELPRO did. So we put it on a 900 megahertz platform, which gives you some pretty substantial ranges, and then cranked out the maximum power that FCC permits to get the maximum range out of that. Today, the largest network we have of those meshing radios is approximately 3,000.
And can you tell me exactly what your unit is doing? I'll go ahead and have that described in the notes.
If I could ask you all to just mute your microphone. It sounds like we have a conversation in the background there. And again, a reminder, if you've just joined, we are recording this session. We have all of the usual approvals required for radios: FCC, Industry Canada up here, ATEX, UL, CE, etc. So we've gone through, we're very familiar with the certification processes involved. ELPRO was the first to develop a 900 megahertz high-speed, high-powered Ethernet radio. So again, some other companies had developed a high-speed, short-range radio, but we were the first to develop a 900 megahertz long-range version of that same radio, which just means that the distance you can shoot across is increased quite significantly. We were the first to release a protocol converting radio, such as Modbus to Allen Bradley's Ethernet IP or Profibus, etc., etc. And today we have the radios installed in over 70 countries, and we estimate about 500,000 radios installed overall. Okay, this shows where our offices are located today. The company is headquartered in Brisbane, Australia. And today we have myself up in Vancouver, BC. We've got 2 offices in Denver, Colorado, and Tampa, with Tim and Matt holding down those 2 locations. And then we have distributors in almost, well, I shouldn't say every country in the world, in every region of the world would be more accurate. But we do have coverage globally, global representation. Okay, these are the typical markets that we cover. Traditionally, wastewater is about 1/3 of our business. Oil and gas is also about another 1/3 of our business. That depends on the price of oil. And then mining is probably another 10 or 15%. And then the rest of the applications go across the spectrum, power generation, you name it, automation in warehouse, automated guided vehicles, that sort of thing, some renewable energy as well. But water, wastewater, oil and gas, those are going to be the 2 largest markets, or historically have been the 2 largest markets for us. Now, we're going to be talking about the different model numbers pretty quick. So I wanted to give you a little bit of background for the next couple of slides. When we say it's for the radio technology, when we say it's an FF, we mean a fixed frequency radio. And that requires that you get an FCC license to operate that. So we say fixed frequency or licensed radios, and they mean the same. The next one is a frequency hopping spread spectrum. Directly below it's a direct sequence spread spectrum. The spread spectrum radios operate in the license-free bands of 900 megahertz, the 2.4 and the 5 gigahertz bands. And then OFDM, that's another method of modulation that gives you even higher throughput, and that is also used in the spread spectrum bands. Now the model numbers. If it starts with a 1, it's either a 450 or a 150 megahertz older generation radio. If it starts with a 2, it's a 2.4 gigahertz radio. If it starts with a 4, it is our new Condor series licensed radios. And these radios are available in either 150, 450, or 950 megahertz. And again, they're all licensed radios. And the main feature with the Condor series is that they have QAM modulation. Now, I'm not going to jump into too much about what all these different acronyms mean today, but just the point being is that these are our high-speed licensed radios, and there's a couple of different bands that are common where you can get a license in the States. If the model number starts with a 9, it's a 900 megahertz license-free radio. And when we say license-free, that means you can install that radio anywhere in the country, and you don't have to contact the FCC. You don't have to tell your neighbors or anything like that. You're free to operate that radio anywhere in the country. Now, if the model number ends with an E, it's an Ethernet modem, so it's designed to pass Ethernet data. If it ends with a -2, it has 4 to 20 milliamp and discrete inputs and outputs built onto the radio. If it ends with a D, it's a serial modem for sending RS-232 and RS-45 data. And if it ends with a G, it is a gateway type radio and compatible with all the 905U type products. So this is the one slide I'm going to spend a fair bit of time talking about here. It breaks down the product line into categories that we can follow and explain a little bit more easily. So the top row, these are our remote I/O radios. So what we mean by that is these radios all have 4 to 20 milliamp and discrete inputs and outputs. And we make a variety of different modules for different purposes, but you will see some similarities between the two, or between them. So we're going to start with the 415U2. That is a 450 megahertz licensed radio, and it has analog and discrete inputs and outputs built right into the terminal block. It's got 4 analog inputs, 2 analog outputs, and then 8 DIO. Now, when we say DIO, we mean that can be a digital input or a digital output. So it's a programmable digital point, can function as an in or an output. Then we go to the 215U2. Oops, oh, my apologies here. We'll just back that up. Then we go to the 215U2 and the 915U2. Now they are identical in terms of the I/O count that to the 415U2. The only difference is the frequency. So the 215 is at 2.4 gigahertz and the 915 is at 900 megahertz. And there's very specific reasons why we offer essentially 3 radio products here that all have the same I/O count and do very similar functions. And the main reason is the distance that you can get at these different frequencies. The 415 at 450 megahertz, we allow up to 10 watts of transmit power on that radio. And if you can get up to 10 watts of transmit power, you should be able to get a range of about 50 miles, absolute maximum. With the 915U2, operating at 900 megahertz and capped at 1 watt of transmit power, you should be able to get approximately 20 miles of range out of that. And the 215U2 is a much, much shorter range radio. It's designed for short range networking. That radio is going to have a maximum range of about 1 mile. So different ranges, different price points, and different distances are what differentiate these 3 products. Then we move over to the 415U-1. This is a new product that we have recently released. It is essentially a 450 megahertz radio inside of a weatherproof enclosure. This enclosure also can house a battery inside of it, whereby you should be able to get between anywhere from 6 months to about 1.5 years of lifespan out of that battery, depending on the sampling interval. Naturally, the faster you sample, the shorter the lifespan of the battery. It also has the option for a solar panel as well, so works very well for remote sites where we don't have any power. The next is the older generation of radios here, the 905 series. So the 915 is the newer meshing radio that has the latest protocol inside of it. The 905 radios have been on the market for, I think, between 15 and 20 years now, and very, very tried and true products. They really did pay the bills for ELPRO for many years. And got us very well established in the marketplace. So the 905 ULTR, this is a transmitter and receiver pair, and it's just a one-way device. So you've got the transmitter on the left, the receiver on the right, and they come factory paired together. And it's just a very inexpensive way of sending one 4 to 20 milliamp signal and 2 contact closures over a distance of up to 20 miles. With this radio here. So then we move over to the 905U-1, or this radio is also available in a 450 megahertz and a 150 megahertz, and it has the model 105U-1. The 905U-1 is probably the biggest selling product. We've literally got, I would say, well over 100,000 of them installed around the world. The 905U-1 has 2 analog inputs, 2 analog outputs, 4 digital inputs, and 4 digital outputs. And it is compatible over the air with any other radio that also has 905 in the model number. So quite frequently, we might have one location that has a 905U-1 receiving signals coming from a 905 ULT at a remote site, or maybe a 905 UK at a different remote site, depending on the need. All these radios could then be transmitting their information all the way back to a 905 UG gateway radio located in a control room. So Very reliable, very great product for ELPRO, the 905U-1. But it has been superseded now by the 915U2 in terms of capabilities now. The next one is the 905U-K, and this is a radio that has one analog input and two discrete inputs. So it is a one-way radio. It is a transmit-only device, and it comes in this weatherproof electrical enclosure. So it does not need to be placed inside of a cabinet. As well, it has a sleep mode built into it. And so one of the really cool things it can do is it can cycle power on and off to a two-wire 4 to 20 milliamp transmitter, like a level transmitter, pressure or temperature transmitter, and turn off the power to the sensor in between readings when the radio is in sleep mode. And this will drastically reduce the overall power consumption. So we offer a battery pack with the 905UK, and that battery pack consists of 6 AA batteries, and you can get a lifespan up to about 1.5 years if you have a fairly low sampling rate. So that's a great product, perfect for remote sites with very limited power resources available. Then lastly, we have expansion modules here. So these are modules that connect via either Ethernet or RS-45 to these other radios here. So if I'm at a remote site here with a 915U2 and I need 7 or 8 analog inputs, and this radio only has 4 analog inputs, I can connect a 115S serial expansion module to the RS-45 port of this 915U2 to increase its I/O count. And we can daisy chain several of these modules all to a single radio to increase the I/O count quite dramatically. So with the 115S, those are serial expansion modules. The 115E is an Ethernet expansion module. The only difference just being how they connect to the base radio. Okay, so that kind of summarizes the remote I/O radios. The next thing to talk about is our gateway type devices. Now the gateways are radios that are usually interfacing to a PLC or a DCS or a computer running a SCADA program, and they communicate using a protocol. So I'll start over here on the right. We have 2 gateway radios here. We used to have a much broader range, but we've gradually whittled down the product line a little bit, just responding to market demand. Some protocols have gone the way of the dodo bird and aren't really used all that much anymore. So we've narrowed it down to the most popular protocols. So this 905UG ET1, this could be located in the control room, and it can communicate using Allen Bradley's Ethernet IP or Modbus TCP. So we can connect this radio directly to like a Schneider PLC and have the Schneider PLC act as the client, and the radio will act as the server, and then communication follows. Similarly, we can have with this one here, the 905UG MD1. This radio can communicate using Allen Bradley's older serial protocol, DF1, or it can communicate using Modbus RTU. So what we typically have is you would have out in the field, you'd have a number of these radios out here, maybe 905U-1s, maybe some 905ULTs, etc. And they would all be sending their data back to a 905UG located in the control room. The 905UG has 5,000 data point registers, so it could handle inputs from literally hundreds of remote radios. So all these remote radios, they transmit their data to the gateway, and the gateway then stores it in registers, and the PLC can then read those registers. Then we move over to the newer generation of radios. The 415, 215, 915U2 that you also see up here, these also have protocols, some protocols built in, just Modbus. So we can do Modbus TCP both client and server modes. As well, we can do Modbus RTU, master or slave modes. So sometimes you might find it's the same radio out in the field as it is back in the control room. Now, I mentioned a little while back that one of the unique capabilities that ELPRO has is protocol conversion. So, for example, in a lot of plants, you might find that for a certain generation, they used Allen Bradley PLCs. Then at some point they switched, and a different department sometimes may have decided to use Schneider PLCs. And so these networks can then not communicate easily with one another. However, these radios do have that capability of converting protocols. So what you could have is at one point in a plant, you could have our ET1 connected to an Allen Bradley PLC. And what it does is it takes the data from a Allen Bradley format, converts it into our generic database, and then we transmit that over the air to another remote gateway. And that gateway then takes the data from our generic I/O database and converts it into, for example, Modbus. So in this fashion, it allows different types of PLCs to communicate with each other when these PLCs each use different protocols. So those are the gateway type radios that we have here. And of course, there's a couple of I/O across the bottom here. We've got 8 DIO on the terminal block here. And of course, these ones have a couple of I/O points as well. But they are primarily designed to be located in a control room, communicating to a PLC or SCADA system. Okay, the third category of radios that we have here, these are the Ethernet pass-through modems. So what that means is that whatever I stick into the Ethernet port of one radio comes out the Ethernet port of the opposite radio. Now, we build a number of different devices because the differences are we've got speed or throughput and distance. Those are the major differences. Now, when you want to build a radio product and it has to be FCC compliant, the FCC has a number of rules. They have caps on the amount of transmit power, the amount of bandwidth you can occupy, and your minimum number of frequencies for a frequency hopper, and all kinds of specifications like that. So adhering to these specifications has led to this portfolio. So we start with the 415U-E, that's an Ethernet pass-through modem, and it's available in 150 or 450 megahertz licenses. We're soon going to be releasing a 950 licensed version of this radio as well. That should be out in the next quarter or two. With 450 megahertz at 10 watts of transmit power, the maximum range is going to be about 50 miles. Now, if we drop that down to 150 megahertz, then the maximum range goes up to about 80 miles. So you can see it's a very long range radio system. Now, when you get a license from FCC, they only give you a fairly narrow slice of the spectrum to make sure that lots of other users can also use radio products in the area. And so your bandwidth or your throughput is going to be limited. So with this radio here, we're able to get approximately 70 kilobits per second on a 12.5 megahertz wide frequency channel. And that's considered very, very competitive today. Prior to the development of QAM modulation, the throughputs were down around 9600 or 19.2. So this has been is a technological breakthrough of a new modulation technique that was able to significantly increase throughput on the same narrow licensed channel. Okay, the next product here, the 415U-BSR, that is a base station repeater. So what this is this consists of two radios inside a 19-inch rack mount housing. And this is going to be used in the control room or a critical repeater point. So for example, if you have a repeater that services 50 remote sites, and if that repeater fails or loses power or the antenna gets knocked over or something like that, then you've lost communications to 50 remote sites. However, this 19-inch rack mount enclosure here has two radios side by side, and they monitor for a variety of different types of failures. And if one system fails, like for example the antenna impedance, we get a VSWR fault, it'll switch over to the second radio and communications will continue seamlessly. So it's really the 415UE. We've took two of these radios here and put it into this housing with a couple of switchover capabilities and some monitors for critical repeater sites. Then we move over to the 905U-E, and this is available in license-free 900 megahertz, or if you're located in Europe, that frequency band is 869 megahertz. And you'll get approximately 15 miles of range out of this radio and throughput of approximately 200 kilobits per second. Then we go to the 945U-E. This is also a 900 megahertz radio, but instead of being a frequency hopper, this one is a direct sequence radio. So direct sequence modulation allows you to get much higher throughput at the expense or the cost of shorter range. So the maximum range with this guy is going to be approximately 9 miles, but you can get throughputs of up to 54 megabits per second. So now you've got a radio system that's fast enough for doing wireless video. And the longest radio link we have installed that I'm aware of with this radio is on the Alaskan pipeline. It's 8.9 miles and it's still in use today. Then we jump up to the 2.4 gigahertz frequency band, and we have another radio, the 245U-E-G1. This one can also do 54 megabits per second, but operates at 2.4 gigahertz. And the higher the frequency, the shorter the range, all other factors being equal. So this radio now has a range of approximately 6 miles, absolute maximum. Then we take the same radio technology, we put it on a 5 gigahertz radio platform, and the range drops down to approximately 3 miles. Again, we've got 54 megabits per second of throughput. So in summary, all three of these radios have the same throughput of 54 megabits per second. They're just at different frequencies, and because the range gets shorter and shorter as you go higher and higher in frequency, that's why we have ranges of 9 miles, 6 miles, and then dropping down to 3 miles. So again, all of these radios do exactly the same thing. The differences are going to be the frequency of operation, which is going to impact the distance and the throughput of the radio. And then lastly, we began offering Ethernet switches a number of years ago. Today we just offer a single 5-port unmanaged Ethernet switch. It's in an aluminum housing. It's industrial temperature rated. The whole works. So certainly not something you're going to see in a typical inside IT department. This is designed to be installed outdoors, out in the rough, where temperature extremes are going to occur, and where you're going to need some reliability as well. And then lastly, we have our serial modems here. And again, these are just pass-through serial modems. So whatever you stick into the RS-232 or the RS-45 port of one radio, come out the RS-232 or 45 port of the opposite radio. We've just got two models here. Again, we don't see too much growth, or we're not anticipating too much growth in the serial market these days. Almost everything is moving to Ethernet, but we still have these radios out for older or legacy applications. The 905UD, we can have throughput of 115 kilobits per second and a distance of approximately 15 miles. Then if we take that same radio and we still have throughput of about, well, actually this one's going to drop down to probably 19.2 kilobits per second, but at 450 megahertz, we should be able to get about 50 miles range out of that radio system. And then lastly, we have our cellular modem. And Our cellular modem, these operate off of your typical carriers, Verizon, AT&T, T-Mobile, or up here it's Rogers, Telus, and Bell. And what these devices do is allow you to connect equipment together, and as long as each cellular modem has access to a tower and is within a coverage area, we can access that information anywhere in the world that has an internet connection. Now, I'll talk more about cellular devices in a slide a little bit later on. There's quite a few interesting applications that we've done with cellular. And then lastly, in the lower right-hand corner, we've got our SCADA Solutions Group. We only offer that in Australia, where they will design a complete turnkey SCADA system involving our radios for you. So we do have some experience in that field there. Okay, so moving on here, I just want to talk about the wireless I/O radios here, just to talk about them in more of a broad sense here. Essentially, what we've done is we've added 4 to 20 milliamp and discrete I/O to a radio in a single package. And that really just kind of simplifies control cabinets. If you have a look down here, you know, you don't necessarily need to have a bunch of extra equipment in the cabinet when the radio is integrated with the I/O. And mainly what we do is we wire up industrial measuring type devices, temperature transmitters, level transmitters, flow transmitters, the temperature switches, pressure switches, that sort of thing, into these devices here. And we make these radios across a global frequency range. So if you're in North America, we would send you the North American version, but if you had a project overseas, we would just ask you what country it's located in, and just look that up and make sure we specify or ship the correct radio with the correct frequency band. And these can be very small systems, they can be very large systems here. As I mentioned, one of the largest installations we have is with a pharmaceutical company, Genentech, in San Francisco, and they're monitoring their freezer and incubator temperatures for their research work. And as I mentioned, they've got about 3,000 of these radios installed, and they really wanted a meshing radio because they move the freezers and incubators from room to room periodically. So they needed something that could automatically use another radio as a repeater if it needed to do so. And of course, we've got all the certifications. Almost all of the products we manufacture are UL or ATEX certified for hazardous areas. There are 1 or 2 products that we have built more recently that do not have that certification, and we offer them at a lower price point if the application does not require that. Okay, and we also have meshing, roaming, and redundancy capability built into the newer platform of radios. So the 415, the 215, the 915, those are all the newer generation radios. They all have meshing capability. And meshing just refers to if a repeater is needed, the radio network will figure out which repeater to use and when. Same with the roaming capability. It means that you can have a mobile application. For example, we've done a couple of applications with automated guided vehicles inside Amazon warehouses. So you've got these machines that are moving freight around the warehouse, and they're able to link to different access points as they move along to maintain communications. So yeah, some very interesting, very cool applications out there. Okay, moving on to the gateways here, just to give you a little more information about their general capability. We've got radios that can do DNP3 protocol, Modbus TCP, and RTU. We have a unit that can do Profibus. We have Ethernet IP, Allen Bradley's Ethernet IP. And in Australia, they have an alert protocol for for flood monitoring as well. So we definitely have a very capable engineering team that are familiar with all of the major industrial protocols that are out there. These radios, as I mentioned earlier, they can do protocol conversion. So we can have one network that uses Allen Bradley products communicating to another network that uses Schneider products, for example. And of course, we have all the certifications. So all of these radios, with one or two exceptions, all have UL approval for Class 1 Div 2, as well as ATEX certification. And up here in Canada, they also have CSA approval as well. And again, like the IO type radios, they also have meshing, roaming, redundancy capability. And these can go from very small systems up to very large networks. The gateways, the 905 UG series have approximately 5,000 data point registers assigned to them. So they could be receiving information from hundreds of remote radios there. Okay, then our wireless Ethernet radios here. Very interesting application. This is a robot being used by a bomb squad by the police department in Australia. And they use our Ethernet radio to remotely control that robot. Of course, there's hundreds of much less interesting applications. We do tons of wireless video, or just connecting corporate networks together. I had one customer that told me he was expanding his business, and they said they just acquired they leased some office space that was on the opposite side of the parking lot from their existing building. And they wanted to get the Ethernet over there so people in the new office space could have access to the corporate network. However, they're faced with a $35,000 trenching and asphalt bill if they wanted to bury that cable underground. So for roughly $2,000, they bought a pair of radios and set up a radio link from rooftop to rooftop for an absolute fraction of the cost and a fraction of the time to install. So tremendous cost savings can really be had by using these products here. And here we go, industrial cellular. First of all, I just want to talk about some of the terms that these cellular radios use. We have OpenVPN or VPN. I'm just going to generically call it VPN. So that is a virtual private network that you can set up to dial from a computer that has internet access into your cellular modem anywhere in the world. And of course, that cellular modem, when I say anywhere in the world, I mean that cellular modem must have coverage from a carrier, must be within a cellular range. But assuming it is, we can now access that information from anywhere in the world and do so securely by setting up a VPN. We also have IPsec, that's another type of cellular security technique. And then we also have more simple techniques like GRE and port forwarding, as well as DMZ for it's a demilitarized zone. GRE stands for generic routing encapsulation. That's probably one of the most common methods that we set up these modems. And what that does is that locks down a modem so that a cellular modem can only communicate with one other specific cellular modem. And that essentially prevents the modems from getting hacked into. One of the reasons why the customers prefer GRE tunnels is because oftentimes it is not possible to set up a VPN connection from within a corporate network. So to bypass that corporate network, they'll have a SCADA computer connected to a cellular modem that now has nothing to do with their corporate network, and they don't have to worry about the IT department getting concerned about access to the network. The cellular modems, they have a couple of I/O points, discrete I/O points on a terminal block on the radio, and we can use them to send text messages. So for example, if a switch closes going into that cellular modem, you can have that cell modem send a text message, and you can just type in whatever message you would like, such as, tank level high. And then when that switch returns to normal condition, it'll send out a second text message, and you can type in whatever you'd like that to say, tank level normal or something like that. So it's very interesting how they're able to interface with these cellular modems. It's not just modem to modem. We can send text messages or emails messages with these devices now. One interesting application of these is hybrid networks together. And that is where we have no cellular coverage using our 900 megahertz or 450 megahertz radios to get that data to a location that does have cellular coverage, and then jumpering that 915 or 415 radio directly into the cellular modem, and now you can get that information back to your head office. So very, very powerful capabilities, and it's quite common that we use a hybrid network of licensed or license-free radios in an area that does not have coverage, going to a cellular modem that does have, getting it to an area that does have coverage. So very interesting, very cool devices. Lots of potential applications out there for these modems here. Okay, here we're going to talk about the market functionality by type of device and where we compete across the spectrum. So the Condor series licensed radios, the 450 megahertz radios, they're going to compete with the Trio radios, the 4RF, the GE-MDS, these types of radios. They're going to be identical, if not exceed the performance of most of our competitors out there. And in some cases, we drastically exceed the performance there. Then in the mid-range category, where we're competing against companies like Oleum Tech or Banner and guys like that, we've got our 900 megahertz radios, like the 915U2. Competes directly with these guys and essentially can do pretty much everything these guys can do, and in some cases more. Then we go down to the short range devices here. These are going to be radios that have, temperature and level and pressure transmitters that have a radio inside, and they use the short range protocols like ISA 100 or wireless HART. And this is where the 215U2 is going to come into play. Now, it obviously does not have the sensor built right in, and it is going to have a greater range than these devices right here, especially the 905ULTR radio with a 20-mile range compared to these guys are going to have a practical range of about 300 to 400 feet. We're going to have a substantial range advantage, but we do compete with these guys a little bit. If you need something where you need to go beyond about 300 feet or get something outside of the fence of a facility, these radios are just not going to have a suitable range here. So that's where we recommend something like the 905 or the 215U2. So you can see we've got radios that pretty much compete in all of the industrial communications markets there. Okay, so now I'd like to talk about a couple of installation examples, show you where we've been and what we do. And this was a project in Greece, their water supply network. This was, what we found was that it was kind of surprising because we thought that Greece was a country that did not have a lot of money to be able to spend on automation. But when the European Union was giving all this money to Greece, they spent it on infrastructure. They had to figure out where to go and spend it. And one of them was for this district of Elasona. And you can see it's, I think there's about 70 remote sites here. And what they did is they gave us all the GPS coordinates for all of these remote sites. We entered that information into a path loss software program and essentially designed their radio networks by telling them where the best repeater sites were going to be located and how high each antenna had to be mounted above ground. So that was a very cool, very interesting application that we did there. This is a dust suppressant system at a coal loading facility. Every time the wind picks up, the coal dust would blow off the loading facilities, off the conveyor belts and everything onto the town. And they had to do something about it. So they monitor the wind speed. And when the wind speed exceeds a certain speed, they automatically turn on these sprinklers to prevent that dust from blowing across the town. So again, just a very simple system. They don't want to waste water by leaving it on all the time. It's certainly not beneficial to do so. So they have a control system to monitor and control that. And here we go, Lithgow. That is a suburb of Sydney, Australia. They had about 75 remote sites. It's just a wastewater application. They're connecting a bunch of pump stations and a bunch of water towers together. And they decided to use our 415U2 radio system so they can get some pretty big distances. And yeah, very successful installation. It's been up and running for, I think, about 3, maybe 4 years now. We also have done some work in irrigation with some irrigation pivots. This is with our South African distributor, and they actually cover the entire continent of Africa. And so they've got ELPRO radios installed all over the continent. And what they're doing here for irrigation pivots is just making sure that each pivot has enough water pressure, that they have enough water flow, and that the variable frequency drive controlling this is set at the right speed to make sure that these pivots at the far end of the pipeline still receive enough water. So yeah, quite interesting how they monitor and automate the irrigation of crops in certain areas of the country. So here we go. This is another pipeline leak detection application here. There's several different applications for this, but I'll just talk about one of them. It was a mine site where they had a pipeline that ran about 6 miles going to a tailing pond. And they had control valves that would mounted every mile or so down the pipeline. The control valves leaked, but they had a holding tank that would store the leaked tailing pond liquid. But these tanks would fill up and they wouldn't be aware that the tanks were overflowing, and they would be subject to a major environmental fine for the pollution. So they put a level sensor on the holding tank, they connected it to a radio system, and now they can monitor all of these holding tanks and send staff out to drain, or send a truck out to drain the tanks only when they're full. And so thus they avoid any environmental, any fines that the government would apply. And of course now it's all automated, so they don't need to send a guy in a truck out every day just to have a look at the tanks and see whether they're full or not. And here we go. This is another, this is showing the inside of a panel here. It's showing, this is our older generation cellular modem. It's connected directly to the 915U2 radio system. And this is doing, as I described earlier, using the 915 to get the signals to an area that has cellular coverage. Once they have cellular coverage, they use the cellular network to get that back to their control room. And here we go, just a couple of snapshots of some radios inside some control panels here. We can see we've got a nice big battery down here, and that's the radio mounted right up top. In this case, this is our newer generation of radio. You can see the newer generation of radio have a much slimmer profile, which means that you can install it in a smaller electrical enclosure and save a little bit of money there as well. And here we go, just showing a very simple antenna installation, just mounted literally right to the outside of the enclosure. And then in the lower right-hand corner, you can see we've got the radio module right here. And then these are our 115S serial expansion modules. So this was a site that had a ton of extra I/O points that they all wanted to transmit via radio back to their head office. So they connect these serial expansion modules via RS-45 daisy chain into the main radio, and use the main radio to get those signals back to the control room. Okay, this is another interesting one here. Highland Valley Copper, it's about 6 or 7 hours drive from Vancouver and sort of the middle of the province of BC. It's the largest open pit mine in Canada. And what they needed to do was to monitor flows and levels, and they needed to turn pumps on and off, mainly for dewatering purposes, but they also wanted to monitor some conveyors and tailing ponds as well. And one of the challenges is that as the landscape, or as they excavate, the landscape changes, and that affects radio propagation. So where it may have been a flat valley, over the course of a couple of months, they could be dumping earth there or ore, and then gradually create a mountain or a hill. And of course, that hill could then block the radio signals. But by using the meshing protocol in the 915U2, it meant that if as the landscape changed and if one radio path was lost, it would just automatically reroute and use a different 915U2 to get the signal back to its final destination. One of the other things I really appreciated was 256-bit AES encryption. As I last checked, it is still considered unhackable with today's computer processing ability. So they felt very comfortable with that, knowing that nobody would be able to hack into their data and make it and be able to dig in and find out, or possibly manipulate or control their information. What's also interesting is that 256-bit AES encryption got us a job at Los Alamos National Labs in New Mexico. And Los Alamos, as you know, they do nuclear research for nuclear weapons, and they were very concerned, even though it was only a wastewater application, everything in that town or that facility has to be very, very secure. And it was the 256 AES encryption that got us that job at Los Alamos. Okay, well, I think we've pretty much wrapped things up here and covered just about everything I can cover here. We didn't get a chance to go through product selection, but I think we'll save that for another session. And again, we'll record that. And so that if you're not able to attend on a future Wednesday, we'll be able to make that available for you. Okay, are there any questions?
Brian, we did have a question come through asking how many radios, if you knew, were deployed at Genentech in Oceanside. Oh,
Genentech, it's approximately 3,000. I heard one of the engineers mention that he thought it may have been 3,300. But he said there are just so many now that they had lost track.
Okay.
But we know it's over 3,000 at this point.
Outstanding.
Brian?
Yes. Yep.
Brian, this is EJ at RM Controls. Good morning. Or actually, probably good afternoon for you. But yeah, I'm sorry. I asked that Genentech question. Do you know if that is specific to the San Francisco plant, or is that amongst both of their plants, San Francisco and Oceanside?
Oh, no, that is exclusive to their facility in South San Francisco.
Okay. All right. Do we have any way of knowing if they have radios at Oceanside other than?
I'm not sure on that. We would need to talk to the folks that installed those to find out.
Understood. Thank you.
Brian, we did have another question came in from Samantha Keebler. Samantha is asking, what is considered a low sampling rate to get around a year's life out of the batteries?
Let's see. I would suggest we would probably need to do some calculations because it would depend on the warm-up time of your level transmitter or your pressure transmitter. But if we're able to get it down to, say, a warm-up time of, say, about 10 seconds, We should be able to sample, I would suggest, probably about 4 times a day should give us about a 1.5 year lifespan, just approximate. Yeah.
Okay. Also, this particular product does have the new solar version that is available as well if batteries are not an option, and you do need significant faster polling times than what Brian just mentioned, approximately 4 times a day. There is a solar option that is available for that as well.
Yep, for sure. And it will depend a fair bit on ambient temperatures in the area, because temperatures influence battery life. As well, the radios all have a low battery voltage alarm. So what you can do is, if the battery voltage is dropping, you can have that alarm point transmitted by the radio to your main receiving location, so you can be alerted in advance that the batteries are getting low and will need replacement or recharging soon.
That seems to be all the questions. Anyone else? Okay. We'll conclude session 1. We will have trainings at the same time every other Wednesday at noon Eastern. So please stay tuned. Join us again, time permitting. And Brian, I'll let you close out if you like. But again, thank you everyone for your time and joining us today. I really do appreciate it.
Excellent. Yeah, thanks, Matt. Appreciate you chairing the meeting here.
My pleasure.
And hopefully we'll see you all in 2 weeks' time.